Lesson 94 on page 293 is called Terms and Adding Like Terms, Part 1. Just want to emphasize one word in this title, adding like terms. This does not apply to, let's say, 4x, times 6y. It doesn't matter that they have different variables. You can multiply and divide just about anything. This is going to be 24xy because we still got the values x and y in there no matter what I stick in for those. But adding 4x with something like 6y, that's a no-no. Cannot do that. And that's the kind of thing we're talking about today. Adding like terms, part 1, which means expect more of this excitement at a future date. Get rid of this dot. All right. How many terms do you see here? Let's do some review. Algebraic expressions and terms are separated by addition and subtraction. But when multiplying a number with a variable, that's just called a term. So how many terms do you see? 1, 2, 3, 4, 5, 6. There are 6 terms here separated by addition and subtraction. But that's not to confuse. Negatives still travel with the term. This is a negative or an opposite of 7y. It's not minus a 7y. But each time we see one of these signs, it tells us it's a new term. So we have 6 terms. Can we turn this into just 3 terms from 6 to 3? Absolutely. That's going to be something we do by combining like terms. We can simplify first by combining any x terms. How many do I have? I got 1 and I got 2. If it helps, you can use shapes or colors and point out that I've got x terms there. I got y terms in triangles, and why not just do some yellow rectangles for the numbers? We're going to combine each of these to turn this from 6 expressions, 6 terms, to just 3. X is put together, x plus 3x, 4x, because there's an implied 1 there, isn't there? Now, y's, positive 2y, if you can see it through all the doodles, this is a negative 7y. Remember that negative travels with it, gives me a negative 5y. And to finish the problem, my 5 and my negative 2 will give me a plus 3. It's not necessary for a term to have a factor that is a variable. A term that doesn't contain a variable is simply called a constant term. Why do they call this a constant? Well, because no matter what I do with this problem, 3 will always be 3. You can't change 3 without breaking the rules. But 5y, I could put a lot of things in for y. What if y equaled 2? What is this middle term? What is it worth? It's going to be a negative 10. What if I put a 3 in for y? It's going to be worth a negative 15. But no matter what happens to 3, it's always 3. Unless I start tossing variables on there. And then p could be 3, right? And then that's a 9. But it's a constant term when it's just a number without a variable. Okay? Remember that term. Book will use it all the time. Next section is called Adding Like Terms, Part 1. We know that multiplication is a shorthand version of repeated addition. I mean, people need to count up groups of 5 over and over. Let's say we have 7 groups of 5 marbles. We could show it this way, but someone figured out this is exhausting. Why don't we use a pattern called multiplication to do this quicker and say I have 7 groups of 5s. 7 times 5 is 35 every time. And then we got a 4 and a 2, which is kind of like saying I have 4 1s and I have 2 1s. This is already a counted up version of this, right? It's 1 plus 1 plus 1 plus 1 is what's going on here. But it's already solved for us in this one. So this next section we want to talk about how multiplication works as repeated shorthand and how groupings really work and why like terms are the way they are, and we can't just put whatever we want together. How does this work? Let's illustrate this fact. You could write 5s in a row that way as 4 5s and 3 5s using labels like that. The way we've got our symbols of inclusion right now, that's the way we should read it. 4, like we said, it's kind of like 4 1s in a parenthesis and 2 1s. What can I put together and what can't I? I can put 5s together. 4 5s and 3 5s will be 7 5s. But I can't put that with this. The 1s can go together to be 6 1s, but I can't be putting the rest of this together. I'm done. Now let's illustrate this fact with x's now. What if we put an x in wherever there was a 5, and then another group of 3 x's, and then leave this the way it was? What's like terms? How do I solve? What do I do with this? 4 x's, of course, would be written 4x. 4 x's plus how many in the second group? 3 x's. 4 1s and 2 1s. Can simplify that down to 6 1s right now. I combined like terms. Can I combine like terms here too? Yeah, because I got an x and an x, and those values will always be the same. So 4x plus 3x is 7x, and 6 1s, just multiply that out. It's just a 6. It's a constant of 6. Can I go any further? No, because x could be a lot of things, and if I decide 7x plus 6 is 13, then I've limited x to only being worth 1. And we don't know that unless the book tells us that. What if x was worth 3/4, right? Then we got a whole nother problem on our hands. We got 21 over 4 plus 6 is a lot less than 13. So we have to stop there. Those are the like terms we've got. Can't go any further. Let's practice this with one problem, and then you get to show me it's as easy as you think it is, right? Simplify by adding like terms. Which terms are like, which ones aren't? If you like this method, circle your x's. Circle your x's. Keep your grouping symbols together. Don't cover them up like I'm kind of starting to do. Triangle your y's. Do I have any constants? Rectangle the constants. Now, put your x's together. I got the opposite of 3x and a 2x. Put that together, and it's a negative 1x, or just negative x. I got y's. Do I have more than just the one triangle? No. So I'm done with 2y, and put my constants together. Those were 2 positive constants, comes out to positive 10. Can I go any further? Can I simplify this more? Do I have additional like terms? No, I do not. If you have any questions about putting together terms with different variables and when to do that, please raise your hand, talk to me. Otherwise, show me both work and answers for, why don't we pick 2 practice problems from A through C on page 294. You show me right answers, good work on that. That's your ticket to problem set 94 for Thursday. Thank you. God blessings on your work.